Hey guys, I'm going to do problem 46 from the chapter 5 homework set. It's a review problem, so it's going to involve forces and kinematics. So let's get started. One side of the roof of a building slopes up at 37 degrees. A student throws a frisbee onto the roof. It strikes with a speed of 15 meters per second, does not bounce, and then slides straight up the incline. The coefficient of kinetic friction between the plastic and the roof is 0.4. The frisbee slides 10 meters up the roof to its peak, where it goes into free fall, following a parabolic trajectory with negligible air resistance. Determine the maximum height the frisbee reaches above the point where it struck the roof. So that's important. Remember, it says the maximum height the frisbee reaches above the point where it strikes the roof, not where it leaves the roof, where it strikes the roof. Okay, so I started by drawing a picture. So up here you can see I have my signings saying I tilted the axes so that this direction would be positive x and that direction would be positive y. So here's the picture I drew. So this is the frisbee, normal force going up, and then perpendicular to the surface, that's normal force. And then straight down from the center of the object is its weight, which equals mg. And then I broke that into its components with dashed lines. And the vertical component of the mg is mg cosine 37 because it gives you the incline of 37 and that's same angle. And then the vertical component is mg sine 37. And then we also have friction, which is going back. And remember, friction equals the normal force times the coefficient of kinetic friction. And then the problem states that the frisbee goes up 10 feet up the roof before it goes into a parabolic path. And this kind of shows, this delta y shows that we're looking for the distance from its maximum height, where the velocity will be 0, to where it strikes the roof. Okay, and then over here I have all these givens that they give us, and we're looking for the maximum height. So the next thing I did was write the sum of the forces in the x direction, which would be this one right here, the negative mg sine 37, minus the force of friction, which is the normal force times the coefficient of kinetic friction equals mass times acceleration in the x direction. Then I did the y direction, and the forces in that direction are just going to be, as seen in the picture, the normal force up and the y component of gravity going down, or weight going down. So that would be Fn minus mg cosine 37 equals mass times acceleration in the y direction, and this becomes 0 because the object is not accelerating in the y direction. So then I solved for the normal force as much as I could, and since the problem doesn't give mass, this is all I could do. But then I took this and I substituted it in to this equation. So down here, you can see I took the sum of forces in the x direction and substituted in the numbers we have. So mg sine 37 minus mg cosine 37 times 0.4, and this right here is the whole normal force, so that's that, times the coefficient of friction, which is 0.4. And then as you can see, the mass cancels out in all of these, so you don't need it to solve the problem. So then you keep going, solving for acceleration in the x direction, and you get negative g sine 37 minus g cosine 37 times 0.4, and you end up getting negative 9.028 meters per second, which makes sense because if you think about it, the object's decelerating due to the friction and the gravity pulling it backwards. So, to continue finding the maximum height of the frisbee, the next thing I did was use that acceleration to find the final velocity of the frisbee right when it's at the edge of the roof before it goes into free fall. So to do that, we know that we're finding the velocity after 10 meters, so I use this kinematic and I just substituted in the values we have. So the 15 meters per second squared is the initial velocity given in the problem times the acceleration we just found times the 10 meters it travels before it goes into free fall, and then I got the final velocity to be 6.66 meters per second. And then after that, after you have that component of the velocity, so that would be the velocity right here, I broke that velocity into components x and y to find what the initial y velocity would be as it left the roof, so that I could find the y direction it would travel from where the velocity is here to where the y velocity is there. So I drew another picture because that helped me more. So the angle was 37, so it's still 37 up here. And that should be 6.66. So let me fix that. Yeah, this should be 6.66 because that's what we just found. And then that means that the velocity in the y direction would be v sine 37. And that's y1. That's the y distance it travels from where it leaves the roof to its maximum height. So then I found the y velocity right there. So it's 4.012 meters per second. And then to find the distance, this y distance, I plugged it into the same kinematic I used above. And remember, the final velocity is 0 because that's where the object hits its maximum height. And I just substituted the values in, negative v initial, so that's that value down here, 2 times the acceleration we found above, and we get 0.8914 meters. So that might feel like the end of the problem, but it's not, because remember, it asks for the entire y distance traveled, not just this distance. So, next page. So we need to find the distance it traveled in the y direction as it covered that 10 meters up the incline. So to do that, it's 10 meters sine 37, which is just that, and it's 6.018 meters. And then to find the total distance in the y direction, I used this value plus the value we found on the previous page, and I got 6.9 meters. And I believe the solution manual says 6.8 meters, and I think that 0.1 meter of a difference is attributed to the fact that I didn't round a lot of the values, like my trig values. I just stored them in my calculator, and so I got 6.9 meters. So hopefully that makes sense. Good luck. Bye.